Good morning, everybody. Thank you very much for joining us for this Climate Academy of the New Jersey Climate Change Resource Center. The purpose of today's Climate Academy is to provide an overview of a new set of data that's been developed by the team at the New Jersey Climate Change Resource Center at Rutgers University that we'll describe in a few minutes associated with design flood elevations. My name is Jean Herb. I'm at the Rutgers University Blaustein School Environmental Analysis and Communications Group. And our team here today on the webinar is Lucas Markson, who is the Executive Director of the Environmental Analysis and Communications Group at the Blaustein School and Co-Director of the Climate Change Resource Center. Dr. Marjorie Kaplan, who's the Associate Director of the Rutgers Climate and Energy Institute and also Co-Director of the Climate Change Resource Center. Senior Research Specialist Pritpal Bramra, Data Analyst Jonathan DeLaura, our colleague and webmaster Matt Drews from Rutgers University. We're also joined today by Kunal Patel from the New Jersey Department of Environmental Protection, who is going to be able to be available sort of on call should questions come up that are more relevant for the NJDEP than for the Rutgers team. This webinar is scheduled for no more than an hour. And the flow for today is that in just a minute, I'll be turning it over to Lucas Markson, who will provide an overview of the new data set. Other members of the team may chime in to provide some additional background on the data set. And then from there, after Lucas's presentation, we'll take a little bit of a pause and see if there are any questions from the participants here today. During the course of Lucas's presentation, if you have questions, you can put them in the chat, and some members of our team might be able to actually answer your questions up front in the chat. If not, after Lucas's presentation, Marjorie is monitoring the chat, and we will call out some of the questions that we've received for various members of the team to answer. During the course of the webinar, we will post links to where you can find this data set on the Climate Change Resource Center website, and we'll put those in several times for people who might join the webinar late. This session is being recorded, and the recording and transcripts will be posted no later than early next week on the website of the New Jersey Climate Change Resource Center, which Marjorie's putting into the chat. And that will be an opportunity for you to go visit that site and see the recording. The data set that's being presented today has been developed in consultation with the New Jersey Department of Environmental Protection, and we are grateful for the collaboration with NJDEP, and is intended to be a data set that is consistent with a recently adopted inland flood rule that establishes a design flood elevation standard for specific types of new construction and redevelopment here in New Jersey. One of the things that you're probably going to hear from us more than once is that this new data layer is meant to be a high-level screening tool for planning references only and should not be relied on for site-specific flood impact analysis, permitting, or legal purposes. The accuracy of the data set's limited by the data and the methods available to create it. It's not based on survey quality data and should not be used in replacement of survey quality data. Rather, it's a planning tool, and the Climate Change Resource Center developed this in consultation with NJDEP because we heard that there were many of you out there who had a strong interest in having access to this type of planning data. The data layer is available on the Climate Change Resource Center's NJADAPT set of data tools and decision support tools, and we'll putting the link to the NJADAPT data set into the chat as well. So with that, I am going to turn it over to Lucas to give an overview of the new data set. Lucas? Lucas, you're on mute.
Thank you.
You're welcome.
Good morning, everyone. So today I'll be going over the Rutgers Inland Design Flood Elevation Dataset for NJDEP, kind of walking you through the dataset we created and where you can find it. So as Gene mentioned, the DEP established a new their inland flood protection rule last July, which established a new design flood elevation standard for specific types of new construction and redevelopment. The design flood elevation standard basically states that construction or redevelopment needs to look at areas that are 3 feet above the elevation of the 1% chance annual flood, or 2 feet above NJDEP's flood hazard area design flood elevation if it's higher. Because we don't have data necessarily on all of the DEP flood hazard area design flood elevations, our data set specifically focuses on 3 feet above the elevation of the 1% chance annual flood. So this, as Gene said, was developed in consultation with NJDEP. And as she said, I'll reiterate, this data set is for non-regulatory planning purposes. It is not for site-specific flood impact analyses, permitting, or other legal or regulatory purposes. And as we said earlier, the accuracy is limited by the data that we have available and the methods available to create it. So to start talking about some of the methods we use to create this data set, the data is based on the FEMA flood insurance rate maps data. This includes both preliminary firms as well as effective firms. The issue that we run into from the get-go is that there are many counties that have both preliminary and effective firm maps available. So in consultation with DEP, we decided to use a conservative worst case extent for the 1% annual chance annual flood hazard, which basically merged the preliminary and the effective, and took the worst case extent for those flood areas. This actually resulted in a new data set that we named the Rutgers FEMA Modified Statewide Flood Hazard Area. So this data set is included in the data packages. I'll talk later, so you'll have that as in addition to the final data set. We also used catchment areas from the Oak Ridge National Laboratory's height above nearest drainage model, and also HUC 12 and HUC 14 watershed boundaries. And these were used to basically create regions for analysis for creating the data set. We also utilized a hydro-flattened 10-foot digital elevation model from the most recent statewide LiDAR data. This was used to basically determine the flood extents based on the additional foot elevation on the 1% chance annual flood hazard area. And then we basically relied on 2 methods to create the DFE data set, topo to raster and an inverse distance weighted interpolation model. So just to give a little more background on these 2 methods we used, topo to raster allows you to estimate hydrologically correct elevation surfaces, and it also maintains a connected drainage structure. It's nice because it correctly represents ridges and streams within the data set. The one downside is computationally expensive. So there are some areas where basically we would hit the limitations of the tool, where either an area would be too large and have too many data points that it basically wasn't able to process. So for those types of areas, we then relied on the inverse distance weighted interpolation. This basically uses an average of known elevation sample points within a certain distance and weights the closer points more than those that are further away. And this model typically works best when elevation points are dense and evenly dispersed. It may not always conform to the topography, but we found that when we used it to fill in the gaps where the TTR wouldn't work, it actually worked pretty well. Another part of our methodology was we identified low-lying hydrologically disconnected areas, and these were extracted and mapped separately. You'll see these as the green areas on the map. So these are areas that are technically hydrologically disconnected, but due to their low-lying elevation and their proximity to the flood hazard areas, they could potentially flood as well. So we include them to show areas of potential risk. In addition, some corrections were applied to the model after the initial processing was done. There were certain areas where the flood extents would basically hit the limitations of the boundaries that we were using. And so in those cases, we would extend the boundaries from, say, the smaller catchment areas to the next largest size HUC watershed, and then would merge that data back onto the original processing output in order to properly show those flood extents. Another area that we had to provide some corrections were on really large unmapped FEMA areas. So these are typically like large areas of state-owned property, such as state forests, where there's no FEMA mapping available. And so for those, we needed to use larger HUCs and a slightly larger resolution surface for the interpolation in order for it to run in these really large areas. The resulting data set was then split by municipality for ease of use, so you can easily zoom and find the areas specific to your municipality, and it allows for improved performance on the web mapping applications that we've incorporated it into. So the data set is available from a few different sources. Like I said, we'll be sharing these in the chat box as well. You can find the data set directly at the NJDAPT page, which the link is provided there. From there, we have two links out. One goes directly to a downloadable data package, and the second goes to a feature layer map service that can be used to incorporate into either online mapping applications or into your ArcGIS desktop environment. We also have it as a flood hazard layer in NJ Flood Mapper, and we have the download package and a link to the NJ Flood Mapper map in our NJADAPT website as well. Just to give a little more information about the data package itself, it does contain 3 separate shape files: the 1% chance annual flood plus 3 feet, the 1% chance annual flood plus 3 feet low-lying areas, as well as the New Jersey FEMA modified statewide flood hazard area. And it also includes a PDF document that includes all the metadata, documentation, and methodology for the creation of the data sets. Just to touch on some future integration into NJADAPT. So now that the data set's being publicly released, we'll be also incorporating to some of our other tools. So the local planning navigator will include this layer in its inland flooding section. Our New Jersey climate snapshots will now include this as a flood analysis layer. So we'll be looking at things such as where critical facilities and critical infrastructure intersect with these layers. In NJHazAdapt, it'll be added in under the lifeline sector and parcel flood analysis. It'll be included as a flood analysis layer for those. And in NJ Public Health Adapt, we'll be including it in our climate conditions that impact health. Also, just want to note that this is a kind of living data set. So as new updated FEMA mapping gets approved, as updated LiDAR data becomes available, and as we find either potential improvements to our methodology, we'll be releasing updates to it. Each data set, as you'll see in the data package, has a revision date, which will indicate newer versions versus older. So any questions? Actually, before we go to the questions, I'd like to quickly just show everyone where the data can be found.
And Lucas, while you're pulling that up, what I want to reiterate, because some people may have joined late, this session is being recorded, and the recording and the transcript from the session will be posted on the Climate Change Resource Center's website that one of my team members will put into the chat, by Monday or so. And so you can go onto that website and you can find the recording as well as the transcript. Go ahead, Lucas, sorry.
Sure. So on the NJDEP page at the New Jersey Climate Resource Center website, if you scroll down to the bottom here, you'll see our new Rutgers Inland Design Flood Elevation data set. There are 2 links here. The Go to Data package will actually open up a link to ArcGIS Online, where we have a full data package that's a zip file that you can download directly from here. And as well, there's the button to go to feature layer, which will bring you to the actual mappable map service. On AGOL, you can open this within Map Viewer, or you can actually open it directly within your ArcGIS desktop applications from there. And then also just to show you on NJ Flood Mapper, if you go to the flood hazards menu on the left here, about halfway down, you'll see we've added the New Jersey Inland Design Flood Elevation, FEMA 1% chance annual flood plus 3 feet. Put some information about it here as well, and you can add this to your map. And then you can basically zoom in on different areas, and it'll refresh. And so you can see the extent of these flood areas, with the green areas being those low-lying areas I discussed previously. And finally, on NJHazAdapt, if you come down into the flood hazard analysis, you'll see now there's a download package here as well. It's the same as the zip file that's available on AGOL, as well as a link to the metadata. And then under the maps section, there's a direct link to NJ Flood Mapper with that data set preloaded, as well as the map service. And this does work based on locality. So if you do select, say, Camden, let's say Camden City, and then select the map, it will open NJ Flood Mapper directly to that location with the new Inland Design Flood Elevation data set preloaded for you. And that's it. So I will open it up for questions.
Yeah, and as we're opening up to see if we have questions in the chat, I want to emphasize that the purpose of this webinar is to provide an overview of this new data layer. Normally we would just post a data layer, we wouldn't do a webinar, but we know that this was a data layer that a lot of you all wanted to be able to have access to, so we thought we'd do the webinar. This is not a webinar providing an overview of DEP rulemaking, so we're asking you to keep questions regarding the rule off of today's agenda, but we will put in the chat a link to the DEP inland flood rules if you have questions about that rule. Marjorie, do we have any questions in the chat?
Yes, we do. We have a couple questions. So Lucas, how is the boundary between the tidal flood hazard area example where these rules don't apply and the fluvial flood hazard area? done or drawn.
So in terms of the new +5 for the coastal areas, are we talking about, or the?
Yeah, I mean, the idea being is that somebody pointed out that your image showed mostly a tidal flood hazard area where the rules don't apply. So how is that boundary fall? And it sort of follows on. It also follows on the next question, which is distinction between this layer and the sea level rise above 5 feet, which is the core part of the real.
I can address both those kind of together. So this analysis purely looked at all of the 1% annual chance flood hazard areas across the entire state, both inland and coastal, just to be consistent and perform the same analysis statewide. However, it's anticipated with the new coastal regulations that those will override any coastal areas. This is really meant purely for inland flood analyses. So there's probably some where the two meet, there may be some interesting issues about compound flood events, but this is really purely meant for inland flood hazard areas and looking at those riverine areas. But like I said, since it's hard to kind of distinguish where those areas may necessarily disconnect, we ran it for the entire state.
Okay. And then will the map layer show the final design flood elevation or just the extent?
It just shows the extents currently. One of the issues with this is that the FEMA flood maps themselves don't necessarily always conform to topography in ways that always make sense. So when we're extracting the boundaries of those flood hazard areas and adding the 3 feet, it's really primarily meant to show the extent. The depth could be it's really kind of an unknown in some of those areas. It potentially could be provided in the future, but for now, we're focusing primarily.
Yeah, and as Lucas said, I mean, all the layers on NJADAPT are layers that evolve over time, based in part on when data is updated, but also based on, in part, on what we hear from our end users as to some of their needs. I believe we have an email address on NJADAPT that if you're using data layers and you have a question or you want to give us some feedback on it, maybe we could put that email address in the chat as well.
Yeah. And one of
Marge, other questions?
One of the other reasons we haven't included depth is, like I said, this is really meant to be a planning layer. It's not meant for site-specific analysis to determine flood depths at specific locations.
Right, thank you.
Okay, we did get one more question. Did you use the base flood elevations provided on the FEMA firm maps or just the polygon to determine elevation of the flood hazard area?
So we had to use the polygons because base flood elevations are only available in the coastal zones. So what happens is we actually use the boundaries of the flood hazard areas and extracted their elevation from the digital elevation models. And then using those, we were able to then add additional 3 feet at those boundary areas.
And Lucas, I don't think the answer to this is yes, it does. But the question is, do the maps show changes to flood elevation areas over the course of several years?
No, it does not.
And then another question is, the layer will be downloadable as a shapefile, correct?
Yes. The data package links that are available will provide you with a zip file that contains shape files for all 3 data sets I discussed, as well as the metadata methodology that was used to create them.
And maybe this is a good time to ask Jonathan Pripple if you could put in the links again as to where people can find the new data layer, because if folks came late, then they don't have access to the earlier chat content. Marge, I think you have one more question.
Yeah, what will happen to the layer when a specific area receives a new preliminary map?
So we're still working on a update schedule for the data set. We'll be checking to see when new preliminary maps are published, as well as when preliminary flood maps become effective maps. So depending on our update schedule, we'll determine when those get incorporated in. So I would anticipate potentially every 6 months roughly. So we'll try and check and see what's available on a 6-month schedule and update the data set accordingly. It is a processing intensive task to do, so it's not something that can easily be run regularly.
So this may be a Canal question. Since the tool is not meant for site-specific evaluation, it cannot be used as a substitute for requesting an applicability determination from DEP on whether the inland flood rule will apply. It's framed as a question, Canal, but
Right. So, I mean, like you mentioned in the beginning, right, this is more of an initial screening tool for the local officials and the interested residents to see whether they need the permit or not, right? They still have to meet all the other regular requirements for the permit. So one thing we found was the local floodplain administrators, they wanted some screening criteria. So this would be the first screening criteria. So just use that, not to meet any of the permit requirements.
thank you. Lucas, are the shape files going to include the DFE elevation, or is it just a group of polygons?
No, it is just a group of polygons. One of the issues you find when you work with the FEMA flood hazard areas is that the flood hazard boundaries themselves can continually change in elevation. So it is difficult in order to provide an overall DFE for those. And since it turns into a single statewide data set, it's just polygon extents. So no DFEs currently.
Great. I think
So-
that's pretty
Yeah,
much it.
so maybe since we have a little bit of time left, I'll call upon Pritpal Bamra to put a link in the chat and maybe share her screen real quickly. One of the things that we did, we often hear from our end users as to a real interest in having the Rutgers team do some analysis of the data that we create. So what you see here on the screen, and we'll put the link to where you can find it in the chat. So this is just a fairly straightforward infographic where members of our team did some analysis to try to better understand, kind of get a glimpse of who and what could potentially be impacted by this new DFE. And so you'll see what the team did here was they looked at some built infrastructure like wastewater treatment plants and evacuation routes, and then people living in overburdened communities and a few other important community assets and critical facilities. So you'll be able to look at that infographic as well. Pritpal, is there anything you want to add?
No, you covered it all.
Okay.
It's just we have links here. You can click on this little icon here or go to NJDAPT from here if you're looking at the infographic. And
That's
yeah,
great.
that's it. We did a little bit of flood analysis like Lucas was talking that we're going to do it and incorporate in other tools. So this is just a brief snapshot of what's to come.
Thanks, Pritpal. Marjorie, I'm turning it back to you. See if we have any questions. And Pritpal, I think we'll stop sharing your screen.
Oh, sorry, I was muted. So
Oh,
I think
sorry.
the question is, will the NFHL be refreshed occasionally to account for, I think they're letters of map revision, the LOMRs?
Yes, same thing. When we do the updates, we'll also be getting the most updated NFHL data sets as well to use in the analysis.
So that's it. We got all the
Okay.
questions.
No, that's great. We knew this would be kind of a quick Climate Academy because you're all gonna need to just go in and play around with this data. So again, the data's been posted, the links are live. So we value your input in terms of going in and seeing how you can use this data layer.
And I think we would just also add that we are reachable, always reachable. Just go to the Resource Center website. You can email us there. You can send
Maybe you could put that email address in the chat again.
well, there's
Contact us. Yeah.
contact us.
Okay.
Yeah, here.
And if you have not signed up to receive emails and news from the Climate Change Resource Center, please go to the Climate Change Resource Center's website and you can sign up to get our emails. Again, this session is recorded and the recording of the session and the transcript will be posted by early next week on the Climate Change Resource Center website. Any members of the team have anything else you want to add? Or are we good to go? Lucas, you good?
Good.
Good. Well, thanks, everybody. Enjoy this beautiful day. Matt Drews, thanks for your help. Managing
No problem. Thank you.
Webmaster again. Kunal, thank you for joining us. We appreciate it. Take care, everybody. Bye-bye.
Bye.